Saxon Math 7-6, lesson 115. I hope you feel smart and accomplished because look at how far we've come in this book. Today's topic is super practical. You may have seen it before, but it is a fantastically useful and everyday calculation that I see grown-ups struggling with all the time. You guys, I can't even tell you. So, if you've seen it before, go ahead, roll your eyes, sigh, go OMG, really again, but then get it out of your system and focus because this is super useful. I'm gonna call it mixed measures. What happens when you're trying to add or subtract numbers that are mixed units? They have different ways of being measured. Here's a great example. I'm just gonna dive right in. Oh, I see this one all the time, you guys. Let's say that you have two jobs that you're gonna do. One you think is gonna take you about an hour and 40 minutes, and one is gonna take you about an hour and 50 minutes. And you wanna know how much time do you need to get both jobs done, right? Well, here is the trick. When you're adding minutes and hours, at some point you have to convert the minutes into hours. So you have to think about what you're doing. So we start by adding the smaller measure. 90 minutes. You say to yourself, 90 minutes is more than an hour. It's actually an hour and 30 minutes, right? Because we subtract 60 minutes and convert it over into 1 hour, right? I'm gonna make this like this. So then, what we're actually, 1 hour. Right, once we subtract the 60 from the 90, we get 30, but now we have a new hour. And so now we're adding this and this. We've already taken care of that. That's come down here. And now we need to add, so it's this and this and this come together to give us 3 hours and 30 minutes total to do that whole job. Okay, so what we did was we added the smallest unit first, and then we realized we had more than enough to make the bigger unit, so we subtracted that out, showed it in our new bigger unit, and then finished the addition. So we had to do kind of a translation in the middle. And the fun thing about these problems, I think it's fun, is that you have to logic out each one by itself. There isn't just a standard rule of thumb that works for every problem. You have to think. And I always find problems where you actually have to think to be a little more interesting. All right, I'm gonna do this one, 6 feet 5 inches. That's how much rope you need to build a ladder to the treehouse. But then that's gonna build you 2 ladders. The first one, so that's the total rope that you have. This is how much you need for the ladder to the treehouse, and you wanna know how much rope you're gonna have left over. Okay, start with the smaller units. 5 inches minus 8 inches. Okay, that's not gonna work. Can't subtract that way. So what we have to do is we have to go over here to where we're counting the feet. We have to take one of those feet away and convert it to inches, right? There's 12 inches in a foot. So when we subtract the 1 foot, we have to add 12 inches to the inch side. Now we have 17 inches because we had the 5 from before and the 17. So now we can do 17 minus 8 is 9 inches. And 5 minus 4 is 1 feet. So that's how much rope we'll have left after we cut off a piece for the ladder to the treehouse. Tricky, right? We had to borrow this time by converting. Okay, so that's the first part of this, which is when we have mixed measures, you have to keep your head and logic out what you're doing. All right, the second part of this lesson has nothing to do with the first. It's multiplying by powers of 10. Okay. I can't remember where exactly we stand in learning something like this. It's called scientific notation. But I don't think we've talked about that yet. So, never mind, I didn't say that. We have a decimal number and we're going to multiply it by a power of 10. Remember that the 2, in this case, the 2 in every case tells us how many times we multiply the number times itself, right? That's what an exponent means. It means that's how many times you multiply the base by itself. But when we're using an exponent on a power of 10, it's also super useful because we can use it to tell the exponent will also tell us how many zeros are in the answer. It's a 1 with 2 zeros, all right? So we know that 6.2 times 10 to the second is the same as 6 times 2 times 100. 2 zeros that came from that exponent. That tells us how many times we move the decimal place to make the number bigger, right? Multiplying by 100 will move the decimal place 2 jumps because there are 2 zeros. But we don't even have to convert it to this because we can see that same 2 up here that will tell us the 2 zeros can also tell us 2 jumps to make the number bigger. So this number we know is 620, right? Because we just bumped the decimal place 1, 2. Huh. Okay. We're supposed to write this number, 1/2 billion, in regular numbers. Okay. So, what we're going to do is we're going to write 1/2 as a decimal number, 0.5, and we're going to write billion as an exponent. Okay, well, I need to remember what a billion looks like. It's it's 1 chunk of 3 zeros bigger than a million. So I know a million is, there's thousands, there's millions, there's billions. Okay, so how many zeros is that? 1, 2, 3, 4, 5, 6, 7, 8, 9. So this would be times, I'll make it an X, that's what we did last time, 10 to the 9th, right? I had to figure out what that exponent would be. I did it by writing out the number 1 billion and then counting up all those zeros. All right, now I've formatted our challenge question here so it looks just like this, and now I can follow the same process for solving it. I'm going to jump the decimal place 1 time for every number in the exponent. Okay, so I'm going to rewrite it here because I'm going to have to do a lot of jumping and that will get messy. 1, 2, 3, 4, 5, 6, 7, 8, 9. And now every one of these I fill in with a 0. It's a lot of zeros. And then I put in commas. So the answer is 500 million. You could have logicked that back here, and Joel, maybe your brain just jumped to that, but I want you to see how you can do the calculation. So on the days when your brain doesn't just jump there, you know how to figure it out. Write the first part as a decimal, write the second part as a power of 10, and then use that exponent to jump the decimal as many times as you need to. Yay, we're done. The 4 problems in the practice set are exactly what we just did. There's one with feet and inches, there's one with hour and minutes. This problem is like the problem that we did, and then these three are all like the last problem that we did, where you get words and you want to convert it into a decimal and a power of 10 to format it just like that. All right, decimal, power of 10. So this would be 2.5 times 10 to the 9th, right? 1.5 times 10 to the 6th. Okay, so those are just like what we did. Watch the video over if it is confusing to you. Always a good advice, right? Watch it over, and you know, plus you can be entertained twice as much by this incredible form of entertainment that I'm providing to you. Okay, I'm gonna stop. 1:15, bye.